N- No, my test was showing like it already submitted, even though I didn't open it.
Okay, fine, not a problem.
So
Uh,
that's why I have low marks. I thought you guys it was 4 marks for grace because you didn't want to give me 0.
it is autocorrect, so it's not in my hand. So it is, yeah, uh, yeah.
I don't really know what happened.
So can you all see the results?
Yes, ma'am. Yes, ma'am.
Yeah, welcome from the last. Gelda, what is your mark?
I
Yeah,
got
why?
Yeah,
Gelda
I don't
for
know how that happened. I actually don't know how that happened.
yeah.
Yeah, ma'am, the same thing actually happened to me. I didn't open the test, but then it just got automatically submitted when I was doing the test.
Okay, fine. We'll look into that. Yes, Muhammad Ryan is there. Muhammad Afan. Is Muhammad Afan there?
Good
Yeah.
evening, ma'am.
What is, good evening. What is this mark? What is this mark, Mohammed? So very first question itself wrong. So
Ma'am,
we,
I was going to take A, but by mistake it got B, ma'am. I didn't check again.
so I have given enough time, 30 marks, and you know very well if you get 1 mark wrong, you will lose -1. So then also you people are doing such mistakes. Take it for granted. Hmm? What? I have given 30 minutes, I have allotted. Very peacefully, you would have did the test. Giving silly reasons. Yeah, why, Afan, you can't even give this one correctly? V is equal to IR. It's a
Ma'am,
very
I was
simple
in this
question.
like this class I didn't attend Ohm's law.
No excuses. No excuses. Nobody should say hereafter, ma'am, I didn't attend this class. That's why I could not able to solve this question. Nothing, no excuses. Slides are always there in the contents. And it's just formula question. It's not a big problem question also. Like for you to understand and write at all. It's just normal formula based question, one word answer. How many times I would have told V is equal to IR, V is equal to IR. Yeah, this question again. What's Gelda? I think yeah, Gelda only. So I have even showed the paper of Gelda. I told C students Gelda has made wrong here. Instead of empire, he has given Watts. Nobody should make this mistake. I especially told. Do you all remember?
Good evening, ma'am.
Good evening, Sudarshan. You gave Watts.
Village.
Okay. Power is different from electric power. Chakrika, Siddhant, Sri Tej, Aishwarya, why only 30? Is Ashwant there in the meeting?
Yes, sir.
What is this mark, Ashwant? What is this mark? What is this question? What happens to the total resistance in a parallel circuit when additional resistors added? It's very simple, no? We talked about series. What will happen if we add extra resistor in the series connection? It's just inverse in the parallel, no? Because the parallel is 1 by RP. In series, it is normal RS. So it will be there if it is increasing, it will be decreasing. It's normal practical thing. And you can even prove that.
Okay.
I clearly told you the question will be tricky this time. Even then, many people have got full marks. See, to decrease the current, to limit the current. Limit is something very different from decreasing the current. Limit means based on the circuit, it will limit. It will know when to limit, when to decrease, increase it. No. Fuse, we are talking about fuse. Limit is very different from decreasing the current. That's why I told it's a tricky paper. Please go through the slides. I never said it will decrease the current. Have I ever mentioned while taking fuse classes? I told it will limit the current flow. It will regulate the current flow. Current is half. Current is actually doubled. Why? Because we have not discussed this question in the class. Actually, we have discussed resistor is double. What happens to current? Yeah, V is equal to IR. It's directly, V is directly proportional to R. So when I increase R, obviously V will also increase. By double the R, V will also be double. The current will also be double. No?
Okay, ma'am.
Rishit, why you have not got full marks? Is Rishit there in the meeting? Rishit is there. Yeah. Why Rishit no full marks? Clap your hands for all the three. Chakrika, Siddhant, and Shritesh. Everybody, unmute and clap. Very good, Chakrika. Well done. And what about these people?
Ma'am, actually, I went out of the station.
Okay, it's fine. Charvik is in meeting.
Even I also went out of meeting.
Okay. Naga Sudarshan, what happened to you? Why you have not attempted the test?
Because I went to my grandfather's house.
Okay, I don't know one thing. Please tell me. See, if it is an objective paper also, subjective paper also, you can say, ma'am, I want to take a paper, I want to write. So I went there, I went here. It's just a subjective, objective paper, just MCQ. You just have to mark it down.
Okay,
You
ma'am.
you can at least omit the, the number of numerical problems. At least theoretical questions, you would have attempted it.
All right. I should do this.
Okay, fine. We'll see a video. Yeah.
Now, what is AC and DC?
It's alternate current and direct current. We will talk about that later. AC means alternate current and DC means direct current. So where and all we will use AC and where and all we will use DC, we will talk about that in a separate session because that is very different world. We'll talk about that later. So now I'll show this video. I hope the sound is audible.
Yes.
Everybody listen here.
A fuse is a thin metal wire that protects a device from too much current. Here's how it works. When electrons flow through a circuit, they create heat in the metal wires. The thinner the wire, the harder it is for the electrons to move, so more heat is generated. When there's too much current, the fuse acts like a weakest link in a chain by heating up more quickly than the other components, and it melts. That breaks the current flow and protects the more expensive components from damage by heat or fire.
If a motor draws too much current too quickly, the fuse will blow.
Understood?
Yes, ma'am.
Got it? How it works?
Yes, ma'am. I got it.
Everybody got it?
Yes,
ma'am. Yes, ma'am.
Just what you taught us, like in the class.
Yeah, just a simulation so that you'll better understand. Should I explain again or is it clear?
I have a doubt. Clear,
Yeah.
ma'am.
Yeah? Who's having a doubt?
My doubt is like if we like any electric object, like if you take a mobile, if you take a the bulb, like if you on the bulb, like let us take an example of the bulb. Or if we like switch on the bulb for too long, the bulb's outer layer, like the glass will it will be very hot. So
Yes.
one time I literally touched it, my hand was like kind of burned. And
Yes.
even with mobile, like when we charge the mobile chargers also get very hot and the mobile also get very hot. So why
Yes.
is like that?
Because current produces heating effects.
Is
Current
there
does
fuse
have
in mobiles?
fuse in the mobiles. No, we don't have fuse in mobiles. We have fuse. We have like basic fuse is everywhere. No, in normal switch box itself we have fuse, so we don't have to have a separate fuse in mobile phones. It's not required actually, because we already have fuse mechanism in all the home appliances. Wherever we go, fuse is compulsory actually. So we have default fuse is attached in the circuits itself. And now you saw how the fuse works, right? So it is not possible to have fuse in mobile phone. So wherever the circuit is there, there only fuse, you need the fuse, right? Yeah, if there is no circuit, then no fuse. Yeah,
Ma'am,
so
what
why
is
is it happening? What?
MCB?
MCB. Where did you see MCB?
Like we have two things we keep it down. I saw in a book.
Which book? No, MCB is related to what?
Like offing the current. It acts like switch only.
It's
Similar
like
to
the full form of MCB is miniature circuit break, I think so. I'm not
yes,
sure.
ma'am.
Miniature circuit break. Yeah, it is by the name suggests it's helping in that only. It is also like, you know, kind of we can say, but not exactly. It will be having differences. I'll read about that and tell you. I don't know much about that. I just know the MCB full form is miniature circuit break. But if you want to learn more about that, we'll have. I'll first learn and then I'll teach you. Okay. It's not so. It's not so big. I think so. It's not so like fuse. It's not very much popular. So yes, Siddhant, you asked me, ma'am, how it is. How it is, burning my hand when I touch the bulb, or how you can feel the heatness in your mobile phone. So you will also feel the heat everywhere wherever the electric current is there, you will feel the heat there. In bulbs, in mobile phones while charging. Also, I don't know how many of you use laptops. I mean, everybody of you use laptops. So when you use the laptops for longer time, when you put charge and use for longer time, you can feel the heat in the laptop base, right?
Yes, ma'am. Like in the charger also.
In the charger also, exactly, you can feel the heat. So why is that all happening? It's because of electric current. So wherever the electricity is there, everywhere heat will be produced. So you cannot ask me how, ma'am, because it is nature. It is nature. So wherever the electric current is there, it produces heating effect. It also produces magnetic effect also. So for now, we will not go to the magnetic part. We will go only to the heating part. So heating effect of electric current. So that is today's topic actually. And very important thing, I hope everyone is clear with this lecture. So I'm closing this PPT. Everyone is clear till this sum, right? Till Ohm's law, till these two problems last class we solved, right? I'll be giving more circuit problems as a homework, no problem. So we won't solve any more circuit problems, any more problems based on Ohm's law, any more problems based on QT, that is I is equal to Q by T, that is this one, batteries. We won't go to this part because this particular part of the chapter is over. So we are closing one part of the chapter. Now we are entering into second part of the chapter, that is heating effect of electric current. Yes, so you won't come back to this one until unless you have a very important doubt, we will come back. So I hope everything is clear in this,
Ma'am,
right? Yeah.
like when I was in, I guess in my 5th grade, I like made an electric circuit and took it to school. But at the time I touched the bulb, it had like, it was very hot. It burned my.
I'm afraid when I kept
That's basic because
TV router, the fire began to burn and melt the TV router, right, ma'am?
I
That's
think
basic
so.
because a bulb converts heat energy, chemical energy, heat energy, and heat energy to light energy.
We have conversion of energy, a lot to talk about that. For now, we will talk how the electric energy is converting to heat energy. I mean, not converting, you cannot say exactly converting. Whenever the electricity is present, their heat energy is automatically it will have, because electricity will produce heat effect. So that is why you feel heat wherever the electricity is there. So we'll deep dive into this topic. So when an electric current passes, this is complete theory. I won't say complete theory. You have problems. See, you have Joule's effect. So we have something called Joule's effect. This won't be there in your book. So it is only present in the slides. So this is called as Joule's law. We'll talk about that. So we have this Joule's, and we will be talking about the explanation of the current, and then I'll just show you an overview. Okay. So in this heating effect, we will see what is heating effect. Yeah, in this we will see what is an heating effect. And then we will see how the Joule's law is found, like how the Joule's law is working. And then we'll see the explanation of the formula. We'll see how the certain things that we use in day-to-day life, electric heater, electric iron box, room heater. So these are the things, some of the basic things that is using heat effect with the help of electric current. So how it is all doing. So we'll see that. And yeah, this is a picture of that. And we will solve problems. So these are very, very important problems again. So in class, we'll solve these 1, 2, 3, 4, 5 problems. In homeworks, I'll give another 10 set of problems you will solve. Okay. So basically, this slide consists of only Joule's effect as the main thing, main part. But this slide, I think these two problems involves the Ohm's law also. One problem involves Ohm's law also, and Ohm's law plus Joule's effect, both. It will be like you have to combine both the laws, both the formulas, V is equal to IR and also H square RT. Both the formulas you will be need to combine, and then you will be need to solve. So problem solving will come later, and then we'll have the applications of Joule effect. So what is application? Already you would be knowing how the heating effect is helping us in day-to-day life, right? Iron box, electric heater, solar panels, everything, right? And then we will see practical consideration. So how to use and everything. And then in your book, they have given this bulbs. So in CAD, S in bulbs, and then fluorescent bulbs, CFL. So it's extra thing. I don't want to actually cover this, but your book is, your books are there. In your books, these topics are there. So I want to read this also, because your NCRT book is covering all these things. So these things are not there in your NCRT book. Joule's effects are not coming in your NCRT book, but we should learn, because for your competitive exams, this is very important. So we will learn Joule's law. Okay.
Ma'am, this Ohm's law there.
Ohm's law is there, and then Joule's heating effect. Yes. Please listen the class very carefully. It is very easy, I'll tell you. It won't be very complex. It's not like the circuit diagram, circuit problems. It's very easy. But if you don't listen, it is complicated. Okay? Its theory part is more. Okay, so no problem. When electric current passes through a conductor, like high resistance wire, the conductor becomes hot after some time and produces heat. Yes. So we know this, which is very common thing. So as we discussed, heat is produced whenever the electric current is there. This is called heating effect of the electric current. So wherever the current is passing through the conductor, you will feel the heat in the conductor, right? As somebody told, charger and electric wires. So charger is nothing but the wire, and from the wire you are getting the current to your laptop, right? So wherever you feel, you see the electric current is there, everywhere you will feel the heat effect. Yes. I hope you know how fuse works, right?
Yes, ma'am.
Basically, when overheat comes,
Yes,
so
ma'am.
in that video they told, no, when it overheat comes, when there is more passage of electricity, more heat will be produced, and that heat will eventually melt the fuse. No, correct? Melt the fuse.
Ma'am, like any wire is connected through of that fuse.
Yeah. Okay, you're asking wire. Yeah, it is connected, no? Basically, see here, this is a bulb. Just take this is a bulb. Okay. And this is a switch box. So, you know, the connection will be like this. So when you on the switch, the electricity will pass through here. You know what the electrician will do? They'll put a fuse here. So what will happen? they'll put a fuse here. So what is this fuse is actually like this. It's just a connection between this part and this part. That's all. Just a connection between this part and this part. When the electricity starts flowing, it will produce heat. No, just now we saw whenever electricity is there everywhere electricity will produce heat effect also. So when there is a lot of heat is producing more heat, the fuse cannot tolerate that. So fuse will have the amount. So this particular fuse, for example, it cannot cross 20 amps of current means. So 20 amps of current, some joules of heat will be produced. Maybe some 20 joules of heat will be produced. For example, you remember. And the unit of heat is joules. Unit of heat is joules. What is unit of heat?
Joules.
What is the unit of current?
Amps.
Amperes.
Not say amps. You should
Ma'am,
say
what is the SI unit of heat?
SI unit of heat is joules.
Ma'am, not like
Ma'am, is it like while we are studying about the heat, like we'll just like talk about like in some part like we'll talk about like that conduction and all,
Yeah.
like the conduction, convection, and that radiation.
Conduction, convection, radiation. That is not covered in your part. But if you want, I'll cover. Conduction is there. Conduction is there, but radiation and convection is not there.
No, ma'am, because I had a doubt there as well.
Okay, we'll see that. No problem. But conduction is important part. So SI unit of current, SI unit of heat is joules. And so when Ashwant, so when there is a passage of electric current, so more heat will be produced. When there is more heat, this fuse will melt. So if this fuse melt means this connection to this part and this part goes out, right? Because the
Yes,
fuse is only acting as a connection. If the fuse melts, there will be no connection. So this bulb will be saved. If more current is going to this bulb, the bulb will explode. It cannot hold so much of electricity, right? So to save the bulb from extra electricity, so we are having something called fuse, and the fuse is working based on heating effect. Now did you understand how the fuse works? It is based on heating effect of electric current, right?
okay, ma'am.
Yes, Advika, are you getting it?
Yes, ma'am.
Can you tell me what I said now?
Ma'am, yes, ma'am. Ma'am, so you said that about a fuse, like how it works, when there's like a switch and it's like, it is like giving excess heat, it's generating too much heat, the fuse will melt and it'll, you can replace it with another fuse and the other expensive things will be there, like it won't get damaged.
Correct. Everybody getting it? Chakrika there in the meeting? Yeah.
Yes, ma'am.
Gelda,
Yes, ma'am. Sure.
you got it?
Yes, ma'am.
Hamza?
Yes, ma'am.
Yeah, Afan, sorry. Muhammad Rayan, Afan only, Afan, yeah.
Yes, ma'am. You continue with Rayan.
Yes. Soumya,
Yes, ma'am.
everybody got it? So now
Yes.
we'll continue the lecture. So example, a bulb becomes hot after it's used for some time. So as Siddhant told, bulb will become hot. I don't know how many of you know this bulb of this bulb. I'll show the image. This bulb. Is this bulb is there in your home now also, people?
I'm like it's
Ma'am,
not
like I have.
it in my grandmother's house.
Yeah, though it basically glows in orange color, right?
Yes, ma'am. Yellow or orange.
Yes,
In orange, the basic bulb. So this is Galileo found this bulb only first. Yes. So it's a basic bulb.
ma'am, what kind of bulb did this Thomas Edison found?
Edison. What kind
Yes,
of
ma'am.
bulb is this? Is a basic bulb. So in those times, this was the bulb. So it produces lot of heat, and that heat will also affect us. That heat radiation will come, and the room itself will become hot, and sometimes it bursts also.
And do
Yes.
electricity produce radiation?
Yes. It produces. Yeah. A bulb becomes hot after what? Do you all know what is radiation first?
Ma'am, how does tungsten help in the heating of bulb?
Tungsten
Because
is the
tungsten-
metal.
Tungsten is a good conductor of electricity and good conductor of heat and good conductor of light. Yes. So it is best to use the bulbs.
Filament.
So the bulb becomes hot after some time. This is because of heating effect of the electric current. So wherever you have electric current, everywhere you have heat. So heating effect of electric current is also known as Joule's heating or resistive heating. Please remember the heating effect of the electric current is called as Joule's heating. The name is Joule's because the Joule is the scientist found that heating effect. He gave the theory behind this heating effect. He gave the theory of this heating effect. So they named it as Joule's heating effect. Okay. So it's a process by which the passage of an electric current through a conductor produces heat. This phenomenon is described by Joule's first law. So which states that, so we have, I don't know, we have a lot of laws. So in that Joule's first law, it's telling about heat effects. Heat is produced in a conductor is directly proportional to the square of the current passing through it and the resistance of the conductor and time for which the current flows. So mathematically, it is represented as H equal to, please note down the formula, I square RT. So here I square, you know what is I, you know what is R, you know what is T. Yes, we learned all these things already.
What
Yes?
is that symbol?
Ma'am, like in the
between,
slide, there is
A
like,
to RT?
ma'am, like in the slide, like there's one symbol.
Where?
I'm like H equals to in the slide, right? Like in the formula slide,
Yeah.
like H equals to I, then you give one symbol, then you RT.
It's power, it's power. So we in computer, we use
I square.
power like this. So instead of writing 2 like this, computer cannot write 2 like this. I mean, it can write, sometimes it won't work. It's subscript. We'll say it's a subscript and you will see here, wait. We have something called subscript. You will have, so
Ma'am,
that
so
was
it is
not
basically
working.
like
Power,
heat equals to
I square.
current square
Yeah,
I square
RT.
multiplied by resistance and time.
Yes, exactly. So please note down this formula. It's very important and you will have problems to solve. Okay. So basically heat is directly proportional to square of the current and resistance into time. So again, I'll ask you the basic questions. When I increase the resistance, so what will happen to heat?
Ma'am, the heat decreases.
When I increase the resistance, what will happen to heat?
Ma'am, I think the heat will like decrease.
Okay. Soumya, can you tell me when I increase the resistance? So this is a formula. So when I increase the resistance, what will happen to heat?
Ma'am, is resistance directly proportional to heat or indirect?
I don't know that. You should say. Yes, Soumya, are you there in the line? Soumya, are you there in the line? Not there. Yes, Aishwarya, tell me. If I increase the resistance, what will happen to heat?
I think the heat will also increase.
Okay. Okay, fine. Your point of view is heat is will increase. Yeah, Siddhant, what's your opinion?
I think like if we're talking if the resistance is increased,
Heat will increase or decrease?
heat will increase.
Okay, fine. Yeah. Shrita is not there in the class.
Ma'am, I'm there.
Okay, sorry. Yes, Shrita, tell me what will happen to heat?
Ma'am, I'm thinking it will increase, ma'am.
It will increase. Okay, fine. Fine. So why it will decrease, Rishit? You said it will decrease. No, why it will decrease?
Ma'am, I don't know, ma'am. Like I just guessed it.
You guessed it. Why? What is there to guess? You have the answer in your front, right? There is nothing to guess. So whenever I told you, whenever you say something in physics, you should prove that to me. If you cannot prove, you should not say. Yes?
I think it could be ideology like it's like an ideology that like it is it is directly proportional and something like that. He took that point and
Yeah,
he
of
said like
course. You can see now from the formula. Yes, Siddhant, you can see that from formula. H is directly proportional to I, H is directly proportional to R, H is directly proportional to T. Right?
Okay.
So when if I'm asking you I is equal to Q by T, so this formula I hope everybody remembers. So when it comes to I is equal to Q by T, if I'm telling if I increase the current, what will happen to time? You should say the time will decrease because I is inversely proportional to time. Right? Here it is all directly proportional. So no confusion. If I say if what will happen to I square if I increase H, you should say it will also increase. Right?
Okay.
Now
Mom, maybe he got confused with that.
you should not get confused. Now I'll ask you one question. So just take it, for example, in the Joule's equation of heat, I am making the current as okay, wait. I am increasing the current into 4. Now, what will happen to my heat? Prove it. What about heat? Prove it. I know the current will also increase, but you have to prove it mathematically. Yes. Start solving the sum, everybody.
Ma'am,
Can
can
you
you
repeat?
repeat the
Can
question?
you
Ma'am, can you repeat the question?
Better I write it. If I increase the current 4 times in Joule's heating equation, what will happen to heat? Prove it mathematically. You have to derive it. You have to derive it. Yes. Yeah. Yes. Start.
Ma'am, I know the answer like the heat will increase, but like I'm like confused like how to prove it.
Yes, from me.
Ma'am, like, can I like I think I can use the formula.
You have to use the formula. Only then you can prove, right? I is equal to, H is equal to I square RT. So with the formula, you prove me. Yes. Very easy, no?
Ma'am, like it's given like you can just say like in words like it's given like the heat is 4J, like 4 times J. So the I think it's 4J will be
Yeah, 4I.
like is it like 4J is directly proportional to
Where is J coming here, Siddhant? So I'm telling you, if I increase the current 4 times in Joule's law of heating, or like, sorry, Joule's heating equation. Joule's heating equation is this one only. Everybody knows, right? Yes or no?
Yes, ma'am.
This is the Joule's heating
yes.
effect. This is the Joule's heating effect. So what I have given, if I'm increasing the current to 4 times, so it means I have to, I square is there. So I'm increasing the I square into 4 means I have to just multiply into 4. That's all, right? So 4 I square into RT. Now I'm telling what will happen to heat. So what will happen to heat? I have to put like 4 square equal to, keep only this side and make everything that side. So if you have, if you put like that, did you understand? This is in the multiplication.
I got it.
Then convert it into
Like,
division.
can you like explain again? I just got confused.
See here, h is equal to 4i square RT. Okay. So now I want to keep only the 4i square RT into the left hand side or right hand side. You can say keep any side. Take everything else to the next side. So R and T is in multiplication. So if that goes into that side, it goes by division, right?
Yes, ma'am.
So just I have written that 4i square equal to h will be there. I am not disturbing the h.
Ma'am, why are you saying I square?
Because that is a formula.
Ma'am, like, what happened? Like, it's saying joules. So, like, it's 4 times in joules. So, 4 times in joules means it's about talking about a heat, right? Because current is nothing related to joules.
Joule's heating equation. Joule's heating equation. This is called as Joule's heating equation. This formula is
Ma'am,
called
so
as.
the question is saying that in joules heating equation,
Yeah,
the
this is the
current is
Joule's
4
heating
times.
equation. This is the Joule's
Yes, ma'am.
heating equation. Yeah.
So it's saying that the current is increased 4 times.
Yeah, in Joule's heating equation, I am increasing the current 4 times. So this is the Joule's heating equation. In this, I am increasing the current 4 times. So 4 into I square. Still confused?
No, ma'am.
Yes, ma'am.
Everybody got it. Gelda, Hamza, Rishit, Saumya,
I'm still
Aishwarya,
confused.
Ashwant.
We need to find the 4 square. So that's the reason the heat came to this side. So it became division.
Yeah. So what was telling you? What were you telling, Gelda?
Now I said that I'm more facing like less problems with this.
Means you are understanding it.
I'm slowly understanding it.
Okay, fine. I'll go very slowly then. So the question is, this is Joule's law of heating equation. Okay. Basically, you can say in our own language, you can say formula for heat. Okay. So Joule's law, Joule's heating equation means it's heat formula. That's all. That's all. Okay. So H is equal to I square RT is a formula that I have already given to you. Yes, that is given to you. No problem. This is given. So now I'm telling you in this equation, instead of I square RT, I am increasing the current. I is current. Everybody knows that, right? I is current.
Yes.
Yes, ma'am.
Yes, ma'am.
Yeah, in this I am making, instead of I square, I am increasing the I 4 times. It means I am multiplying 4. So I'm increasing the current 4 times more. So what will happen to heat? We all know that heat will also increase 4 times. Okay, everybody know that because H is directly proportional to current. When you increase the current, heat will increase. That is what we are learning till now, right? That's why heating effect is there, right?
Yes, ma'am.
Understanding, Gelda, everybody?
Yes, I'm
Yes.
understanding.
So now I am putting 4 into, because in the question they have told you have to increase the current 4 times. So I am just multiplying it with 4. Now I'm rearranging this equation. So this is equation number 1. So I'm rearranging this equation. So I'm keeping 4i square this side. Just I need only 4i square alone one side and rest all the other side. So 4i square is this side. R and T I want to send it this side to H side. So basically R and T is in multiplication. So if I want to send R and T, both of them to this side, I have to send them as a division only, right?
Yes, ma'am.
1 second, wait here.
Ma'am, I'm done, ma'am. Ma'am?
Am I audible?
Yes, ma'am. You are audible. Ma'am,
Okay, so see here 4i square equal to H by RT. And then we are just rearranging it. And now we have to prove that H will also increase 4 times, right?
Yes, ma'am.
So how we should prove this?
How should we divide if we don't even know the value of H and RT?
H by RT, 4 will come down. So what will happen to heat? It's actually heat is reducing 4 times. It's not possible.
Yes, ma'am. That's why like I was confused.
4 I square equal to H by RT. 4, okay. So you have to multiply and
think-
divide by 4 on both sides. I think so.
Yes.
Okay, this is going more. I'll solve independently in a notebook and send you. Okay?
Okay.
But do solve that question. Okay? You also try solving.